Video, we're going to quickly cover the distance formula and do a couple of applications just to show that it works. But the distance formula, it's a very convenient formula. You see I've written up here on the top left here, it says given 2 points, x1, y1, and x2, y2, the distance between them can be expressed as d, and we say d is equal to the square root of this entire quantity right here. And I know it looks very unattractive here, but we're going to rewrite this by hand just to make it look a little bit better, and we'll talk about why it is the way it is. But we say d, the distance d here, is equal to the square root of an entire quantity, and we have two differences in here that have been squared and summed. So we say this is x2 minus x1, where we just subtract the x values of the 2 points that we have, and we say y2 minus y1, where we subtract the two y values of the points that we have. And so let's go ahead and kind of illustrate this and why it works the way it does. But let's just say in general here we have our coordinate plane, but we have 2 points. We'll call this first one here x1, y1, x1, y1, and we say this point up here would be like x2, y2, some second point with its coordinates here. But we could say we want the distance between them, and we're classifying this as the letter d. So what I want us to recognize is this. In the rectangular coordinate plane, the nice thing about it is this. We say, well, since we know the coordinates of these points, we actually know that these distances here are x1 and x2 of those points, and we know that these y-axis distances here, this would be the y height of the first point and the y height of the second point. But what we could do is we could always, using the distance formula, we could necessarily just make this into a right triangle. And the nice thing about right triangles is we could just use the Pythagorean Theorem to find this distance d. And so in order to do this, we need to know the other two lengths of the legs of this right triangle. And the way we're going to do that is we're going to find how far apart say the x values and the y values are. So let's think about this geometrically speaking. But if I wanted to know this distance, say here, this distance in terms of x, this side of my triangle, what we could do is we could take the x value of the second point, so x2, and subtract off the x value of the first point, and that would give us just that distance. And likewise, we could do the same thing with our y values. We could say take the height of the second point, subtract off the height of the first point, and you get this leftover section right here. And according to the Pythagorean theorem, which, if you recall, given a right triangle where we typically refer to C as being the hypotenuse, but we could call this like A and B here, but we say it is always the case that this leg squared plus this leg squared in a right triangle always equal the hypotenuse that's been squared. So in this instance, what we're going to say is this. We'll take the x distance, and you look at this picture we've drawn here on the left, we say x2 minus x1, that distance will square it. Plus now the other leg squared, and the other leg was y2 minus y1, so we say y2 minus y1 squared, and this equals the hypotenuse squared. And in this case, we're calling the hypotenuse this distance d, so we say d squared. But what we want is just d, so that's what leads us back to this formula right here. In order to get d squared to be just d, we take the square root of both sides, and it yields this formula. So now that we know this, let's do a couple of examples just really briefly. But in this first one here, we say, I would like to find the distance between the points 4, 7, and 8, 1. It is always good practice to draw a picture of this. As a matter of fact, let's pop over to GeoGebra here. You'll notice that I've already graphed these points. We say over 4 up 7 is this point A, and over 8 up 1 is this point B. But what I would like to do is find the distance between them. So to sort of illustrate this, what we'll do is we'll drop in a segment from here to here. But in reality, what we really are doing is this. I'm going to graph a couple of lines. We'll graph the line y equals 1, which will give us that height there. And we'll graph the line x equals 4 to give us that there. And what you can kind of see, I hope, is this, is we have this triangular region right here. But we could make this into a right triangle. So what I'm going to do is I'm going to drop on a point here at the intersection of those two lines we just made. But we said, you know, if I knew these distances, and we can find these, we say the distance between B and C, you notice it writes here 4, BC is 4. And change in height from a height of 1 up to a height of 7, those two coordinates, the change in y values is a height of 6. But we could have just done this by using the distance formula, but we'll come back to that image in just a moment. We should always start by graphing the situation. So now graphing this, we say, 1, 2, 3, 4, 5, 6, 7, 8. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is good enough here, but we say 4, 7. We'll put this in a different color. So now this is just a rough sketch, not as good as what I've drawn over in GeoGebra. But we're finding this distance here. And so Making that right triangle that we had just formed a minute ago, what I want you to notice is this. This is the point 8, 1, and this is the point 4, 7. We could say in order to find this distance here, the height, okay, what we could do is we could take the y value of this point minus the y value of this point. So we say 7 minus 1, 7 minus 1. And so this equals 6. And of course down here we could just count. We say 1, 2, 3, 4. Actually, this should be out at 8. I apologize. I put it at 7. But to get from 4 out to 8, we could just say 8 minus 4. So 8 minus 4 is, of course, 4. And so using the distance formula, here's what this would look like. We'd say the distance between them, and that's what we really want to do. I'm really big on let's just fill in some blanks here. So we'll just take out all of the variables that you saw up here in the original expression that we had written, or right here if you want to look at that. But we say x2 minus x1. So now x2, which was the x value of the second point, we say 8, minus the x value of the first point, which is 4. So we say 8 minus 4, that squared, plus now this quantity squared. We say the y value of the second point here. Notice we're doing this time, we say 1 minus the y value of the first point, which was 7. It gives us a negative 6, but what you'll see is this, it's not going to matter as we are squaring these quantities. We end up with this. We say, okay, so we get 4 squared plus negative 6 squared. But when you square those quantities, what you end up with are positive numbers. So 16 plus 36, so this becomes radical, it seems, 52. And so, we can leave it as radical 52. Heading back over to GeoGebra here, we say radical 52. Let's go ahead and find the distance from A down to B here. We say 7.21, and what I'd like to do is this. If we hop over here, I guess I can't use the square root of 52 on that calculator, but if you take the square root of 52, you get 7.21, which is what we wanted to yield. Also this, I would like to say that we should probably reduce this radical, and this is the same thing as, let's see here, I think 4 goes into this. 4 goes into this 13 times, and the square root of 4 is 2, so we'll put that 2 out front. So this distance is 2 radical 13, which is approximately that 7.21 that we saw over there, so 7.21. So the last example here, I'd encourage you to try by yourself before I go ahead and show it, but we say, let's find the distance now from the origin out to the point 1, 2. So I'm going to kind of exaggerate our marks here. 1, 2. This would be the point 1, 2 right here. I'm going to label this 1, 2. And so we could use the distance formula to do this, and as a matter of fact, I do want to use the distance formula to do this, but another thing to consider is this. It's really easy to just make this into a right triangle situation. Say, look, if I took 1 squared plus 2 squared, that would equal this hypotenuse squared, or distance squared. So we end up with 1 plus 4 equals d squared. So 5 is the same thing as d squared, and therefore d is the same thing as the square root of 5. However, just wanted to show this with the distance formula. Again, we say d equals, let's go ahead and take everything out of our original formula. So we have our first quantity squared plus second quantity squared. And let's work with this. We say the origin has coordinates 0, 0. So we say, all right, so x2 minus x1. The x value of our second point here is 1. So we say 1 minus the x value of the first point there is 0. The y value now, y2 minus y1. So y2 is equal to 2 minus 0. And what you end up with is the same thing that we yielded before when we drew a picture. We say 1 squared plus 2 squared. So we get the distance between these 2 points is 1 square root of 1 plus 4, so distance equals radical 5. So a distance formula. Let's get used to this and memorize it.